You're watching my lesson on proportional reasoning. This is part one of this lesson. In part two, I will show you a quick shortcut you can use to check your answers. So let's start with what is a proportion, or what is proportional reasoning? Well, in math, a proportion is the comparison of two equivalent ratios or rates. Two equivalent ratios or rates. So we've talked about ratios, we've talked about equivalent ratios and done them a lot. And we've also talked about rates. So now we're going to compare two different ratios or rates and try and fill in certain blanks. Now we've done something similar to that in equivalent ratios, where I would give you one ratio and then a second ratio with a missing piece, and you had to find the missing piece. And so we're just going to do more of that. So proportional reasoning is when you use your understanding of the parts to solve problems. For example, 3 can fit into 30. This is a proportion. But how many 3's fit into 30? Well, 10, right? 3 can fit into 30. You know, if you have 30 spaces, you can fit 3 things in there, right? Well, how many sets of 3 can you fit in there? 10 sets of 3, right? The reasoning behind that, so the proportion is 3 to 30, right? The reasoning in the proportional reasoning is to prove it, right? 10 3's add up to 30. And so you can prove that by adding these 10 3's together. And that proves your proportion by giving the reasoning, hence the name proportional reasoning. So proportional reasoning can also be relative. It doesn't have to be hard numbers. So a question here would be, which one is more purple? And so you're looking at A and you're looking at B. Now, at first thought, or first glance, you may say, well, they're the same. They're both the same amount of purple. But if you look at B, you know B is much, much smaller than A, right? So more of B is purple than the purple in A, right? It's about halfway. This is about 50% purple, right? And this is more, I'm going to say 75% purple, right? So it's relative, right? If you looked on it on its own, yeah, A and B have the same amount of purple, but if you look at A and look at how much purple there is relative to the white, and how much purple there is in B relative to the white, you can see that there's more purple relative to the other color, or the white. So you could say that B has more purple because it's just more of it is purple. Proportional reason can be relative in different ways. So we can look at this question and say, if one dog grows from 5 kilograms to 8 kilograms, and another dog grows from 3 kilograms to 6 kilograms, which dog grew the most, right? Although both dogs grew the same amount, right? From 5 to 8 is 3, and from 3 to 6 is also 3, the second dog doubled its mass, while the first one grew less than half, right? We went from 5 to 8, right? So it grew 3 kilograms, but it's not as big of a change from 3 to 6, right? It doubled in mass. Here, it didn't double. So you could say the second dog grew more relative to its starting or end mass. So here's our reasoning. Dog 1, 5 kilograms to 8 kilograms. Of the total mass, the dog grew 3 out of 8. So the proportion will be 3 out of 8. This is the dog's growth. Of the total mass, the dog grew 3 out of 6 kilograms. So this is the dog's growth rate. And so we can see it grew 50%, while this one grew less than 50%. And so you could say, relatively, that dog 2 grew faster than dog 1. Understanding the relationship between proportions is important in everyday life. This can be used for determining the cheapest price of things, taxes, and to even drawing maps. So if you remember scale, right? Proportional reasoning is used in scale. The proportion or the size of the map is related or is proportional to the actual size of the country or landmass. So this is China, right? And so this map is proportional to the actual size of China. If you were to blow this up X amount of times, you could make this the size of China and it would be accurate. And so understanding the relationship between proportions is important for understanding many different things and many things in life. So it is quite applicable. So how to do proportions mathematically. When proportional reasoning appears in a question, they are usually asking for a missing value. For example, John takes 30 minutes to read 60 pages. How long would it take him to read 150 pages? Well, what we know is that it takes him 30 minutes to read 60 pages. How long does it take to read 60 pages? So it's 60 pages, 30 minutes. That's our, if you remember, rate, right? Using this rate, we want to find out how long it would take him to read 150 pages. So we have 150 pages in a certain amount of time. And we do not know what x is. We don't know what that time is. But we do know it's 60 pages every 30 minutes. And he has read 150 pages. So how long did it take him? Well, that's what we're looking for. Well, the relationship of the two have to be the same, right? It's still John reading the book, and John's rate has been given to us. It's 60 pages every 30 minutes. So this rate should be true here as well. It just needs to be equivalent. Well, the first thing you're going to look at is say, well, 60 cannot turn into 150, right? 60 times 2 is 120, and 60 times 3 is 180. So I cannot turn 60 into 150. So if I can't turn 60 into 150, how do I find x, right? If I can't multiply 60 into 150, if I can't turn it into it, how do I find it? But they have to be equivalent so we can simplify, right? There are two ways you can solve this question. The first way is to simplify and use your reasoning. The second way is a little bit more mathy, and it's cross multiply. So we're going to talk about simplifying. So again, we have our rate and unit rate, and a unit rate is a rate where the bottom unit is 1. Once again, 80 kilometers an hour is a unit rate. 160 kilometers in 2 hours is a rate. So these represent the same thing, but the first one, this guy here, is a unit rate because that bottom value, this bottom unit, is 1. So this is usually found by simplifying the rate. This is found by simplifying the rate. So if I simplified 160 kilometers for 2 hours, you would get 80 kilometers per hour. So let's simplify. It takes John 30 minutes to read 60 pages. How long would it take him to read 150 pages? So we know that these two must be equivalent because it's still John reading it and we know his rate. So then we simplify this. Well, 60 and 30, we can divide both into 2 pages every 1 minute, right? Because we know that 30 is half of 60. So if we divide this by 30, that's 1. If we divide this by 30, that's 2. So 2 pages per minute, and so it's 150 pages, X amount of time. So using this, how can I turn 2 into 150? Right? How can I turn 2 into 150? And so that's how I want to find x, because whatever I do here, I must do here. Right? Whatever I do here, I must do here to keep that equivalence, to make them the same rate. Right? So we know that every 2 pages, John reads 2 pages in 1 minute. Right? We know that every 2 pages read is 1 minute. So the minutes is half the pages, right? So I turned 2 into 150, and I turned 1 into something else. Well, I have to change both by the same amount. So 2 times 75 would give me 150. Well, that means I have to do this, times 75, which would give me here, 1 times 75 is 75. So then the answer is 75 minutes. So it would take John 75 minutes to read 150 pages. So hopefully that made sense. You simplify the rate into its unit rate, usually. Then you look at the rate and see what can you do to turn the first number, or the simplified one, into the one you're looking for. So try these ones on your own. A car can travel 280 kilometers on 20 liters of gasoline. How far can it travel on 4 liters? So I like to write down what we know. It's 200, right? It's 280 kilometers. Now make sure you keep your units. This will help make sure that you don't make mistakes if the question gives you different units, because I might do that. So 280 kilometers in 20 liters of gas, right? Well, I want to know how far it travels on 4 liters of gas, right? So I turned 20. So in this case, if we look at our equivalent ratios, I've turned 20 into 4. Well, how do I turn 20 into 4? I divide it by 5. Okay, well, whatever I do to one side, I have to do the other. So I have to do 280 and also divide that by 5, right? I also have to divide that by 5. So 280 divided by 5 is, 56. So I know that I can travel 56 kilometers. Sorry, that's terrible. The mouse is not working for me. 56 kilometers on 4 liters of gas. And that's all you got to do. So try this one on your own, and then try this one on your own. And just follow this. Write down the rate or ratio that you do know, and then equal it to a ratio or rate that you need to figure out or need to complete. And that's basically proportional reasoning. And so this will cover the one method of simplifying ratios and rates. And then we will talk about the second way, which is a little bit trickier, but it's a good way to do other things in math and science when you do chemistry. So thank you for listening, and I'll see you next lesson.